In this video, we're going to talk about working with solutions, specifically doing some straightforward dilution calculations, and then also working with solutions that have been diluted and figuring out what the concentration of the original solutions was. So, what are we talking about? We're talking about presumably a solution of, I don't know, 100 milliliters in a volumetric flask, and we're starting with a solution of concentration 0.2 molar. What are we doing? We're taking a small amount of this, let's say, I don't know, 25 milliliters, and we're transferring those 25 milliliters to another volumetric flask, and we're going to dilute to a final volume of, let's say, 100 milliliters. The question is, what is the concentration of the final solution? So one approach is to use an equation that a lot of students use, which is M1V1 is equal to M2V2. The molarity of the first solution times the volume of the first solution is equal to the molarity of the second solution times the volume of the second solution. But oftentimes, this, while it could get you the right answer for this problem, won't help for a more complicated problem like the one we'll do in a few moments. And more importantly, it doesn't get across the true understanding behind what's going on, which is this. In these 25 milliliters that we've taken of our first solution are a certain number of moles, a certain number of solute particles. They are the solute in the new solution. So by finding out the number of moles we brought from the first solution, we know the number of moles in the second solution. So let's do that. Number of moles of solute. Well, we know that every liter of that first solution has in it 0.2 moles per liter. And we're taking 25 milliliters, so 25 milliliters. Well, milliliters and liters don't cancel out, but milli just means 10 to the minus 3, so we'll plug that in, and we get 5 times 10 to the minus 3 moles of whatever solute this is. Now, this is not just the number of moles of solute in the original 25 milliliters, but it's also the same number of moles of solute that's in my new solution. So if I want to find out the concentration of my diluted solution, all I need to do is take the moles of solute and divide it by the volume of my new solution. So the moles of solute is that 5 times 10 to the minus 3 moles. And my volume is 100 milliliters, so that's 100 times 10 to the minus 3 liters, which gets me 0.05 molar. And that's the concentration of my diluted solution. The interesting thing to note is M1, that's the molarity of the original solution, that's right here. V1, the volume of the original solution, that's right here, because I only took 25 milliliters of that original solution. So M1V1 really means moles of solute. And what's V2? V2 is the volume of my diluted solution. So really, we did use M1V1 is equal to M2V2. We just described it in a different way. This kind of problem is a little straightforward. Let's do one that's a little bit more difficult, but comes up a lot. So let's say we made a solution in lab, and we don't really know much about it other than its volume. So we have a 100 milliliter solution, but we don't know what its concentration was. But then we took from this solution, I don't know, maybe 5 milliliters, and we diluted those 5 milliliters to a volume of 250 milliliters. We do this a lot of times because we start with a very concentrated solution and we need a little bit more dilute solution. Sometimes we even go further and have to do a second dilution. So maybe we took 10 milliliters of that second solution and we diluted that to a final volume of 100 milliliters. And we did some chemistry, maybe used a calibration curve or a Beer's law experiment, something, and we determined the concentration of this solution, and we determined that the concentration of this solution is 5 times 10 to the minus 3 molar. The question is, what is the concentration of my original solution? Or, better yet, how many moles of solute are in there? So to do this, we have to work backwards. And again, I think that there's an easy way and a not so easy way. I would always start by drawing this out. I'll never get confused if I draw this out. Let's figure out how many moles are in this final solution. So let's figure out the number of moles of solute in there. Well, we know that it's a 5 times 10 to the minus 3 mole per liter solution. And I know that the total volume of that solution is 0.1 liters, 100 milliliters, which means I get 5 times 10 to the minus 4 moles of solute that are in there. Now, that's great, but we want to know how many moles of solute are in here. Now, they're not the same. The number of moles of solute in, let's label this solution C, are not the same as the number of moles of solute in solution B. The number of moles of solute in solution B are much larger because C moles of solute came from 10 milliliters of the total 250 milliliters of solution. So if 10 milliliters out of 250 milliliters times some total number of moles of solute is equal to 4 times 10 to the minus 4 moles, then X must be 125 times 10 to the minus 4 moles of solute. A much, much larger amount. And it makes sense, right? This is about 25 times bigger than the moles in C. Well, what about, let's call this guy over here solution A. Once again, we have more moles of solute because we only took 5 out of 100 milliliters to make solution B. So how many moles of solute are there in solution A? Well, I know that 5 out of 100, let's call this guy over here Y, moles of solute, are equal to 125 times 10 to the minus 4 moles. So if I do that, I get that Y is equal to, so this looks like 20 times larger, 2,500 times 10 to the minus 4 moles in A. So if I want to know the concentration of solution A, I'll take the 2,500 times 10 to the minus 4 moles, divide this guy over here by the volume, which is 0.1 liters, and I get 2.5 molar. So a couple of straightforward dilutions and undilutions. Hope you found this useful, and stay tuned for more videos.